Hi, this is Steve Smith. Welcome to this Pluralsight on-demand module on the Don't Repeat Yourself principle. The Don't Repeat Yourself principle, or DRIVE, is one of the fundamentals of object-oriented design and software engineering, and personally I think that this is one of the most important principles for every developer to learn. In this module, we'll start out by defining the Don't Repeat Yourself principle, and we'll go through a demo showing how misuse of this principle results in spaghetti code that's very difficult to maintain. After a little bit of analysis, we'll go through a series of demos showing how we can refactor such code to dry it up and make it much easier to maintain and continue to use. We'll briefly look at some code generation options before moving on to show what repetition in your process can do and how it adds to the waste of your process. And then we'll show a quick demo of how we can automate our process to apply dry as well. Finally, we'll wrap up with the summary and related fundamentals. If you've been following this series, you probably know that I like these motivational posters. This one I produced myself, and as you can see, it shows the punishment for repeating yourself should be something like repeating yourself at the chalkboard. I do believe that repetition is the root of all software evil, and that most of the major problems and bugs that crop up in software or that make it more difficult to maintain could be avoided through the proper use of the Don't Repeat Yourself principle. This principle was first coined in the Pragmatic Programmer book and stated as every piece of knowledge must have a single unambiguous representation in the system. Note that these pieces of knowledge are not just values, but they might also be processes or algorithms or approaches to problems and abstractions in your application. In the book 97 Things Every Programmer Should Know, I noted that repetition in logic calls for abstraction, repetition in process calls for automation. Variations of the DRIVE principle include once and only once, as well as duplication is evil. Now let's take a look at a demo of a simple data warehouse example that I wrote, which violates dry all over the place. And then we'll see how we can clean this up by applying this principle. In this sample application, we have a data warehouse loading program, which we're calling Extract Transform Load, or ETL. ETL is a common pattern in data warehousing. If you do a search for that pattern, you'll find a number of commercial products that focus on data warehousing solutions. In this case, the basic steps that we want to apply is to extract some data from our data source, perform some kind of aggregation or transformation on that data, and then load this into our summary tables or our data warehouse, and then finally finishing up the program. In this example, I'm going to be talking to the Northwind database, as you can see here in my hard-code connection string. My extract method is going to open up a SQL connection, perform query against invoices, and put the data into an invoice table. It's going to do some logging and output what it's doing as it goes. Then it's going to open up another connection, also to Northwind, and it's going to query the employees and store this information in an employee table. As it goes, it'll write out the results. In our transform step, we're going to first take that list of shippers that we loaded in the load section in the extraction method. And we're going to go through each one of these shippers, get a count of them, and basically take out the sum of the freight that that shipper received over the period of time that we loaded. When we're done, we'll also calculate the total freight from that period of time as well. Next, we'll go and analyze the employees. We'll pull out whether or not that employee is a manager, based on how many employees report to that employee. And then we'll calculate the bonus for each employee based on that calculation of whether or not they're a manager. Finally, now that we have all of our data, we're prepared to load it back into our data warehouse. So we'll have to open up another connection. In this case, we're talking back to the same data source, but in a real system, it would likely be a different one. We'll clean up any data that was already there. And then we'll insert our records with our new summary data. We'll do the same thing for the employees, cleaning up what was there, and then inserting new records for their bonuses. You can see that this set of code is about 100 lines of code, and the only classes in it are our main program class here, as well as a class for freight by shipper, which simply shows the shipper name and the freight that they charge during that period. And for employees, these employees simply have a name, whether or not they're a manager, and their bonus. If we run this code, we'll see that it all executes. It finishes up in not too much time, and you can see that it's logged all of the things that we expected to out to the console. Now let's see what we can find as violations of the don't repeat yourself principle in this code and what we can do to correct it. A very quick analysis of the code shows a number of problems with the don't repeat yourself principle. These can be broken out into the following bullet points. First one is the use of many magic strings or values throughout the code, followed by duplicate logic showing up in many different locations. There's repeated if-then logic in some branches of the code, as well as the use of conditionals instead of polymorphism. There are some repeated execution patterns where the same couple of lines or several lines of code are executed with some slight variation over and over again. And there's a lot of duplicate, most likely copy-pasted code that we can probably find with an automated tool and clean up. We have only manual tests in the code at the moment, and there are a lot of static methods which we'll see can also prove to be problematic. There are quite a few examples of magic strings values in this code. The first one is the use of the connection string being hard-coded throughout the code. Obviously, this is not a good practice and something that we should move to a more secure location, perhaps. In any event, a single location that defines our connection strings for this application. Formatting strings are also specified in many different locations, as well as these blocks of for each logic that does things to the console. If at some point we want to change how this data is formatted, or if we want to change where it's being displayed, these would need to be updated in many different locations. Another section is using magic numbers. In this case, the number 1 is specified in multiple locations here, without any indicator of why it is significant. And again, there's the use of formatting strings here that are repeated in multiple locations. Let's look at how we can apply derive to remove magic strings. We're going to look at applying the derive principle to remove some magic strings and values from our application. We've analyzed it and found that there are a number of cases where we're setting this connection string over and over in our code. We'd like to move that to a single unambiguous location that defines the connection string for the application. One option would be to move this to connection strings. We would do this by adding configuration manager, which we'll have to add a reference to. We'll add a reference to .NET system.configuration. And configuration manager has a connection strings section where we can specify a name for this. We'll call it the main connection string. Connection string. Now in order for this to work, we'll also need to add a new app config value. And within our app config, we'll add a connection string section with a new connection string. We'll paste in the actual connection string we're using. And we'll also give it a name. By doing that, we can delete the source here and run our code since we have no actual tests. And if it still seems to work, then we can be confident that that's working. However, if we go through and add this logic that specifies the use of configuration manager everywhere that we're using a connection string in this code, we'll simply have changed one kind of duplication in exchange for another, because now if we later decide to change what that name of that value is for main, or if we decide to use a different method of storing the connection string or passing it into this method, we're going to have to change this in many different locations. So we've improved where the value of the connection string is stored. That's no longer repeated. It's only in one place here. But we haven't gotten rid of the repetition in how we get to that connection string. So to do by simply pulling that method up to a class level variable. So we'll say string, connection string equals this value. And we'll replace this with this. And then there's a refactoring that we can use here, where we can introduce this as a field called underscore connection string. And now we're using that underscore connection string field. And if we move this initialization code up here to the beginning of our main method, we can then use underscore connection string throughout for all of our connection strings. I think that's all of it. So now if we run the code again, it should still work. And it does. And at this point, we can see that we've pulled out a fair bit of repetition into this one line, and now aggregates all of that information in one place. Another thing that we saw when we analyzed our code was the frequent use of two things. One being this console write line, another being the use of this format string. And in fact, this entire for each loop is somewhat repetitive. As you can see, we're doing it both for our invoice table here, as well as down here for our employee table. We can apply an extract method refactoring in order to pull this data out and give us a common way to write it out. If we want to pull out this logic for writing out the number of rows inside of a data table, rather than working at the row level, we can simply create a new method that takes in the table and dumps out the results using this kind of format. We'll start off by creating this new method. And at this point, we simply want to take the logic we had before, for instance, this for each loop, and convert it so that it's using our table. However, we want it to work over the number of columns the table has. So we'll do something like this. We've added in a bit of logic here that will determine what total number of columns is, and then move through those columns, adding in the row with that column index, and then a hyphen between each one, and then finally a right line at the end if we don't have any more columns. This will dump out all of the columns in the table. If we want to actually limit this, because for instance our actual usage up here is perhaps only showing a certain number of columns, 3, even though it's selecting all the columns in the table, we can pass in a column count. So int columns to display, let's say, and we'll use that here in place of column count. So instead of just table.columns.count, we'll say it's going to be that. But if columns to display is greater than 0 and less than column count, we'll say column count equals columns to display. And we can delete this old console right line we had before and use our output table method now in place of these locations here. So we'll say output table, and we'll pass in invoice table, which we want to show 3 columns. And we can have our columns to display have a default value if we want to, just limit that 0. We'll do it. Now let us pass in nothing for it when we use it down here for our employee table. Now if we run this, it hopefully will still work. And it does. If we scroll all the way to the top, we'll have to turn off some of the logging here to make this easier. Let's just do our load and run the show. These are all the invoices being output. And again, these are our customers, our employees rather. So you can see it's still working the way it did before. We have a hyphen separated columns. The next magic value that we had in our application appeared in our transform section, where we're doing these if statement checks. And we're checking whether the count was greater than 0, then we're grabbing the first item. If the count was greater than 1, then we grab the second item, which has index 1. And this number 1 here is the same as this number 1 here and this number 1 over here. And so we could do a simple change to say something. Obviously we could fix this in several ways, but the simple change here to remove that magic number is to have something like int index, which we'll set to 1, and then replace those 1s with our index value. Now if we need to change that, even if it's a copy-paste change, we won't forget one of those 1s when we do it down here, and we have these 2s instead. We'll see how we can clean up those if statements in a separate refactor. Then the other thing that we have here is a format string. This is for formatting numeric values, decimals in this case. If we want to pull that out, it would simply be a matter of creating a new value. We create it here, for instance. And then where we want to display that decimal format string, or we want to use it rather, we would just replace it here, and here, and here, with that format string. Alternately, this method of doing this right line could be extracted out into its own method. In fact, this entire chunk of if logic could be extracted into its own method or its own separate loop that does this work. But again, that's a separate exercise. So at the moment, we've pulled out a number of magic strings. We've eliminated the connection string duplication. We've shown how we can output an entire table rather than having repeat loops for displaying rows. We can apply the same logic in other places in our code where we're doing looping and doing output to the console. And lastly, we've looked at some display format strings and shown how we can easily replace those with a variable in our application. We see that our application has duplicate logic in multiple places. For instance, there's this logic here for specifying how to output data to the console, as well as separate locations where we're opening up a connection. Let's look at how we can apply some refactorings to clean this code up as well. We'll start with a fresh copy of our original solution. Here's our code. And we can see that we have our connection strings duplicated as we did before. And we have logic here for dumping things out to the console, which we would like to replace with a single new method. We also have a number of different places where we're doing this connection logic to open up a connection and get back a data table. We're doing that twice here. As well as down here in the fill section, we're opening up a connection, executing a query. In this case, we're doing an execute non-query call. And we're doing that a couple of times. In fact, we're doing it 4 times just in this one method. Now we can extract out this code ourselves, or there are a number of well-proven tools that will do this for us. Let's look at an example tool. The simplest tool would be to add a Northwind data context using link to SQL. So we're going to go add a new item. We need a link to SQL class. We'll call it Northwind. We'll go over to our Server Explorer and drag on the tables that we're interested in. And see, we also wanted employees and invoices. We set up the property for this. We'll say our intermediate space should be entities, and everything else looks good. Now, if we look at our code, the first thing we're going to do is delete a freight summary. So instead of using a connection, we're going to say using var db equals new Northwind data context. And because we don't have our configuration set up for our connections variable, it's hard coded for now. So within this data context, we want to first grab the one that we want to delete. So our shipper to delete is going to be from shippers in db.freightSummaries, where shippers.name equals the individual shipper and loop that we're on, .name, and the date, the run date equals 8 times after that. We want to select whole record, and we just want the first one. We'll grab that, and for our first, we'll do that here. We'll say db.freightSummaries, delete on submit, shipper to delete first. And we'll go ahead and submit this now. That takes care of this big chunk of code here. Next, we want to insert a new record with the run date and the values from our shipper that we're on. So for that, we'll do basically the same thing. We'll say our shipper to insert is a new freight summary. Now this is our any freight summary that Link to SQL just created for us. And we will say that its freight is our shipper freight, and its name is our shipper.name, and its run date is still time.today. And we want to just do an insert on this. So it's db freight summaries insert shipper to insert, db submit changes. And if we apply this now to this logic here, our using statement, you can see it becomes much smaller at this point. And we should be able to run our code and it should work. And it still does. We would do the exact same thing here, but for the sake of time, we won't show that to you. And so that's an example of how we could use Link to SQL in order to eliminate a lot of repeated ADO.NET code. We're still going to see some repetition in this pattern where we're looping through each one of these and doing some kind of a delete followed by some kind of an insert. And we could certainly eliminate that duplication as well using a different refactor technique. The other duplicate logic that we saw was this output logic up here, where we're looping and dumping out this stuff. We actually cleaned that up in our magic string section, but just for the sake of completeness, we'll show that technique here as well. If we go and we add a method to output the table here, then we can refactor these calls so that they simply say output table with our table name, and the same thing here for our invoices. Taking care to change this, and we only want to go 3 columns for the invoice one. And if we run this, you can see that we're still getting here our employees, and here are our invoices being output as expected. So we've done that refactoring. Let's look at the next one. Another symptom of violations